With the name of Allah Almighty, dear students and all the viewers, may peace be upon all of you. I am Dr. Engineer Majid Amin, Subject Specialist Mathematics, and I welcome you to my YouTube channel, Maths.Physics. We have started 9th class course. Chapter is matrices, and today is the second lecture. We have already recorded one lecture. I am giving you the link. Otherwise, the whole playlist is given in the description. And today we will discuss these two topics: general representation of a matrix and equality of matrices. For general introduction of matrices, you will have to watch my first lecture. Do watch that lecture. After that, you are most welcome for that. In that particular video, we discussed about matrix, rows, columns, size of matrix, and today we will use those concepts. So, general representation of a matrix. If I tell you to write a 2 by 3 matrix A, let's say a 2 by 3 matrix A, it means write a matrix A, capital A, having 2 rows and 3 columns. So, you could write matrix A like this: 5, 1, -9, 4, 0, 6. But the question arises, why did you write particularly 5 over here? You could have written anything. So it is called particular matrix. It is called particular matrix. Like we say in English, common noun and proper noun, country. It could mean any country. But when I say UK, it means United Kingdom. So it is not a general matrix. It is a particular matrix, having particular values, particular entries. So in order to write matrix generally, you will have to use this notation. Element of matrix A is represented by small a. Element of matrix A, please note, matrix A. The element of matrix A will be represented by small a. And we will have to mention two things. One is called I, other is called J. We write them in subscript. I is a number which shows row position, and J is a number which shows column position. And combinedly, they are called indexes. Indexes, students, indexes. I think it is E, indexes. Indexes means numbers which locate the position. For example, if I tell you to write a 2 by 3 matrix A, then you will have to write generally. Don't go for particular numbers. So you should come and write these entries: A11, A12, A13. It simply means A13 simply means A means element of matrix A. A means element. Then these are the indexes. But element of matrix A, which is in first row and third column. Similarly, 1, 1. You will pronounce it as A12, not A12. A12. Element of matrix A in first row and second column. Similarly, this element is in second row and first column. Second row and first column, you should say A21. Similarly, A22 and A23. This is called general representation of matrix A. If your matrix is, for example, capital B, and let's say we write 3 by 3 matrix B, then of course element of matrix B will be represented by small b. So you will write B11, B12, B13. Small b means element of matrix B. Element is always represented by capital letter. You can't write B over here. It should be capital B. B21, B22, and so on. B23, B33. Right, students? For example, this is matrix B. If I say this is matrix B, 2, 9, 5, 4. For example, 10 minus 13. Let's say 8. And if I ask you, please tell me A11 plus B31, B23. It simply means K. It simply means 8 element of matrix A in first row and first column. So he is pointing to this number. This is A11 and B23. B23 is 8. So the answer is 13. It is called general representation of a matrix. Students, what if I tell you, write M by N matrix? Write M by N matrix. It means write a matrix having M rows and N columns. So then you will write like this: A11, A12, first row, second column, first row, third column, and so on. The last element of the first row will be A1N, where N is the total number of columns in this. Like in the previous case, you said K2 by 3. The first element was A11, other was A12, other was A13. If the matrix was a 2 by 4 matrix, then the final element would be A14. Here it is generally N. So the last element of the first row will be A1N. In the same way, the second row will start from A21, A22, and so on, A2N. A31, A32, A33, A3N. So it will go on, and the last element of this first column will be M1 because it has M rows, like it has 2 rows. So the last element of this column will be A21. If the size were 3 by 4, then the last element would be A31. Here, the total number of rows are M. So the last element of the first column will be AM1. The next will be AM2, AM3, and so on, AMN. The last element will be AMN. Hopefully you got it. Okay, students, what did I write? I wrote that two matrices will be equal if they have the same sizes. Their sizes are same. And their corresponding elements are equal. Corresponding means having the same position. Having the same position. For example, A matrix में A11 element will have the corresponding element of A11 will be B11. Suppose the two matrices are A and B. Similarly, the corresponding element of A32 will be B32, of course. So the corresponding elements, all of the corresponding elements are equal. For example, students, if I write for that particular case, I write two matrices, 4, 1, 2, 9, minus 7, 6. This is matrix A and this is matrix B. So what do you see on the board? You see two matrices. Of course, their size are same. It has size 2 by 3, and similarly the size of matrix B is also 2 by 3. Their size are same and their corresponding elements are also the same. A11 in this case is 4, B11 is also 4, they are equal. Similarly, A12 and B12 are equal, A13 and B13 are equal. This is A13, this is B13, they are same. 9, 9, A21, B21, A22, B22, A23, B23, they are same. So these are the two conditions of equality of matrices. So we say that matrix A and matrix B are equal matrices. Now, if it is let alone, numbers are different. For example, this is 3. Of course, they are not equal. They are not equal. This is A13. In this case, A13 is 3 and B13 is 2. They are not equal. But even if they have different signs, let's say we have minus 2 over here, still they are not equal. Equal means equal. 2 and minus 2 are not equal. So in this case, this is 2 and this is minus 2. There's difference of sign, and even if signs are different, we say the two matrices are not equal. And of course, if size are different, how can they be equal? It is out of question. How can they be equal? Here, A and B are not equal because they have different sizes. So the sizes have to be same. And the corresponding elements, they have to be same. All right, students. Now let's try to solve two questions. One question and one MCQ on this. All right, students, you see a simple question on the board. Solve for A, B, C, and D. Means find their values. And this is the given equation. Actually, two matrices are given. So, students, he has given you that these two matrices are equal. And you have to find their values. Now, A and B are yet to be determined. They are unknown for the time being. As of now, they are unknown. But we know that since they are equal matrices, compare both sides. So A plus B will be equal to A plus B will be equal to minus 1. They will be equal. Because if A plus B is not equal to minus 1, if we don't have minus 1 over here, then how will be the two matrices equal? He has given you that the two matrices are equal. It means the corresponding elements are equal. So you compare these two, you got this equation. Now is let's call it equation 1. We will get four equations. And of course, these two will be equal. B plus 2C is equal to 4. This is named equation 2. These two will be equal to C plus D. Let's call it equation number 3. And similarly, 2A minus D is equal to 0, equation number 4. These are four equations and you need to solve them. How to solve add or subtract or elimination? There are different methods. For example, in this equation, we see A and B, here B and C, so the variables are different. We have to get a way out. First of all, we add these two, these two. Equation number 3 plus equation number 4. Right, students? This is equation number 3. 2C plus D is equal to 8. And here we have 2A minus D is equal to 0. So we will add them because they have opposite signs. These two will cancel out. We add them. We got a new equation. 2A is equal to 8. 2C plus 2A. Let's call it equation number 5. Once again, now in these two equation number 1 minus equation number 2 because they have same signs. The first equation can be written as A plus B is equal to minus 1. And this equation B plus 2C, doesn't matter, you write 2C over here or over here, it makes no difference, is equal to B plus 2C. B plus 2C, B plus 2C is equal to 4. Now you subtract them, just change the signs. These two will be cancelled. A minus 2C is equal to minus 5. Let's name it equation number 5. Equation number 6. I can remove these two. Right, students? Now these two equations, they contain A and C. So we can solve them. Equation number 5, 2C plus 2A is equal to 8. And this one, minus 2C plus A. Minus 2C plus A. I hope you understand the basic thing. You could write this as 2A plus 2C. It would be much better for those who are weak a bit in mathematics. The first equation number 5, equation number 5 plus equation number 6. Equation 5, 2A plus 2C is equal to 8 and A minus 2C is equal to minus 5. So if you add them, they will be cancelled. Here we get 3A and 8 minus 5. If you add them, we get 3. Dividing both sides by 3, A will be equal to 3 by 3. So the value of A is determined. Now you can find all of the remaining 3. Equation number 6, if you put equation number 6 implies that A is 1 minus 2C is equal to minus 5. You shift it to the right side, left side, it will be plus 5 and it will go to the right side. 6 is equal to 2C divided by 2C is equal to 3. All right, students, equation number 1. A plus B is equal to minus 1. A is 1. B is equal to minus 1. Shift on the other side. This one minus 1 minus 1 minus 1 is minus 2. And at the end, students, you will determine the value of D from equation number 4. We can write 2A. A is 1, already determined, minus D. You shift it to the other side. 2D is equal to 2. Hence, solution. Hence, solution of this given problem, A, B, C, D is equal to A is 1, B is minus 2, C is 3, and D is 2. This is the given. So these are the values of A, B, C, D. All the students, and if you enclose them in curly brackets, it is called solution set. I hope you got it. Now let's have a look at the MCQ, a bit conceptual MCQ. All right, students, this is a simple MCQ. He says the solution set of this is. So it seems a very simple MCQ, and it is a simple MCQ, but it is a little bit tricky. A person will come and he will say, it's very simple. The value of x is 1 and the value of y is minus 2, and hence 1 minus 2 is the solution set. Otherwise, it's not the correct option, and he will go for this 1 minus 2, and it means he doesn't understand the meaning of solution set. Solution means the values which will satisfy the values of the unknowns that will satisfy the given problem. If you say that the value of x is 1 and the value of y is minus 2, but he needs x square is equal to minus 1, and it is not possible if you put these values over here. Value of x is 1, y is minus 2, y is minus 2, x is 1. And if you check, both sides are not equal. It will give you 1, minus 2, 4, 1. And of course, this is not true. This is not true. This is not equal. 1 and minus 1 can't be equal. These two are not equal. It is not true. Hence, it has no solution. The given problem has no solution. We say its solution set is empty. This was a little trick that I wanted to elaborate for you. Hopefully your mind is clear now. I think it's enough for this lecture. We delivered our second lecture. Slowly and gradually we will increase the time of our lecture, but it's just the beginning. I want you to get used to my lectures. So I think it's enough. Hopefully you will enjoy my lectures and you will share with your friends as well. Let's meet in the coming lecture number 3. Till then, remember when your prayers. Bye bye.